Hi-ho, Mr. Kaczynski with you. Going to go through the solutions to 3.8 practice your skills. Not a very long one here, shouldn't take us too long. Let's get after it. All right, number one says state the rate of change and the y-intercept of each equation. So in this one, the rate of change can be found right there. It's the coefficient of x. So here's what we'll put. We'll do rate of change equals 3.2. As far as the y-intercept is concerned, there's nothing being added to this, so the y-intercept is 0. All right. On B, there's our rate of change, the coefficient of x. So rate of change is 1.7. And our y-intercept is that value right there, that 3. So y-intercept equals 3. All right, so on part C here, there's nothing being added to that 2.4 as in 0 x's. So our rate of change is 0 in this case. But our y-intercept is there. It's that 2.4. This would be a horizontal line, by the way. Now, as far as D goes, there's a couple of ways we can look at it. Probably the simplest way, though, is to just subtract 2x from both sides of this equation and get y all by itself. So subtract 2x from both sides. Then you can see that the rate of change is not 2, but actually -2. And that the y-intercept is 6. All right. On number 2, we're going to complete this table using this equation. It's got some, what we call that plus minus there is a margin of error. It's a knot tying model like we did in the lesson. Okay. So I'm going to look at this as two different equations. Let's look at this equation first. Y equals 120 minus 0.5 rather, minus 8.5x. Or if we simplified that, it would be y equals 119.5 minus 8.5. I wrote y, even though I'm pretty sure I said x over here, so I'll fix that. All right, so we're going to use this equation to figure out these two values here. All right, here we go. Let's do 119.5 minus 8.5 times 1. And that is 111. Basically, we just took 8.5 off of that. So if we take 8.5 off of this, or use 2 in the equation, we'll get 102.5. Okay, let's go to, that would be the minimum amounts. Let's do the maximum amount. So we're going to do 120 plus 0.5 minus 8.5x. So that would be, if we simplified it, 120.5 minus 8.5x. And that's what we'll use to get these two values, or three values, over here in the right-hand column. So 120.5 minus 8.5 times 0 is obviously just going to be 120.5. And then it's going to decrease 8.5 every time we add 1 to x. So the length of the rope is going to decrease by that much. And you can also see that the differences between the minimums and maximums remains a constant. Let me point out what I mean there. So the difference between these two numbers is 1. The difference of these two numbers is 1. The difference between these two numbers is 1. Just like that's the same here with these values that are given to us. Now we still have to figure out the number of knots that would give us a minimum of 51.5, and a maximum of 52.5, and a minimum of 26, and a maximum of 27. So I'm trying to think of the best way to do that. How about we do like an undoing idea, you know, where we go 120.5. Well, no, we'll take this 51.5. And we'll subtract 119.5. And then divide by negative 8.5. And that gives us 8. Or we could use the other equation. So let's plug in 27. And then we'll subtract 120.5. And then we'll divide by negative 8.5. And that gives us 11. So 8 knots, you can predict that the rope will be between these two lengths, 11 knots that it'll be between these two knots. All right, let's break this down. I've kind of used this stuff in real world terms, but let's talk about it here. What is the real world meaning of that 120 right there? And I would say probably that the starting length of the rope was 120 centimeters. Maybe not exactly, but around there. What's the real world meaning of negative 8.5x? You know what, I'm going to put this in green because it's kind of like our y-intercept, right? So let's put that in green. For this one, what's the real world meaning of negative 8.5x? I'm going to say for every knot that is tied, the length of the rope is 8.5 centimeters shorter. The negative sign tells me that it's getting shorter. So I'm going to put that in red because that's my rate of change. Now, what's the real world meaning of the 0.5, the plus or minus 0.5? I would say this is the margin of error. In other words, the rope will be about 0.5 centimeters shorter or longer than the equation predicts, maybe something like that. So if we only went with 120 and we didn't have that plus or minus in there, then we would say that it's going to be within 0.5, either shorter or longer. All right, a couple more here. We're going to just write equations here. Okay, so this shouldn't be too tough based on what we've done because we can see that the number of knots is going up 1 here. So what's happening here? We'll use our little slope equation, 89.1 minus 93.7. And that is negative 4.6. You can see that our y-intercept is 93.7, so it makes it pretty easy to write our equation. Y equals 93.7 minus 4.6x. And I think we'll go ahead and just do number 5 here right now while we're talking about this one. It says fill in the rest of the table. There's a couple things you could do. You could just take 89.1 and subtract another 4.6, and that gives us 84.5. Or you could use your newfound equation, 93.7 minus 4.6, and then put 2 in for our input, and that'll give you 84.5 as well. All right, moving on to rope B. All right, again, we have this increase in 1 knot here. what's our decrease here? 90.8 minus 101.2. That's a decrease of 10.4 centimeters. Must have been a thicker rope, maybe. All right, so the thing is, we're going to have to go backwards one to figure out this value, because that's the value that we need in our equation. That's the y-intercept. So let's take the 101.2 and we'll add 10.4 to it. It gives us 111.6, which is going to take care of the requirements here for number 5. And now we can write our equation. So let's go y equals 111.6 minus 10.4 times x. All right, that's all I've got for you. Hopefully that helps. Make sure to give me or whoever your teacher is a ring if you've got questions, and we'll try to help you out. Have a good one.